Look at this. Thousands of tons of steel, towering above the ocean, carrying thousands of containers, crossing thousands of kilometers of open water. And yet, it doesn't sink. It doesn't crawl along the seafloor. It simply floats. But there's something even more amazing. This enormous structure can move across an ocean as if the water itself were carrying it. The answer begins long before ships existed. Nature was already demonstrating the secret. A leaf falls into a river and doesn't sink. A branch falls into a lake and floats away with the current. Early humans watched this and eventually asked, what if we made something larger from the same idea? Long before steel, before engines, before giant container ships, humans built rafts from wood. Then came canoes, boats, sailing vessels, and eventually enormous wooden ships. Every generation discovered a little more about the same mysterious relationship: water and weight. But then humans did something that seems completely wrong. We started building ships from steel. A solid block of steel sinks. So why doesn't a steel ship? The secret isn't simply the material, it's the shape. A ship isn't a giant block of steel. Its hull encloses a huge volume of air. That changes everything. The ship spreads its mass over a large volume, and because of its shape, it can push a huge amount of water out of the way.
Now we reach one of the most beautiful ideas in physics: buoyancy. Water pressure arrows become stronger with depth. Water pushes on the hull from every direction, but pressure increases as you go deeper, so the water pushes harder against the deeper parts of the ship than it does against the parts near the surface. The result is a net force pushing upward, buoyant force. A floating ship is constantly involved in a battle between two forces. Gravity pulls the ship down. When those forces balance, the ship floats. And here's the beautiful part. The ship automatically settles to the depth where it displaces enough water to support its weight. More than 2,000 years ago, an ancient Greek scientist named Archimedes noticed something profound. Archimedes. When an object enters water, it pushes some water out of the way, and the amount of displaced water is directly connected to the upward buoyant force. This became known as Archimedes' principle. Buoyant force is equals to fluid density times by volume and gravity. The greater the volume of water displaced, the greater the buoyant force.
But floating is only half the mystery. How does this giant mass actually move? Deep inside the ship, an engine produces mechanical power. That power turns a shaft, which turns the propeller. The propeller doesn't grab the ocean like a wheel grabs a road. Instead, it accelerates water backward. And because the propeller pushes water backward, the water pushes the ship forward. It's Newton's third law in action. Ship pushes water backward, water pushes ship forward. The ocean becomes the road. But unlike a road, the ocean never stays still. Wind creates waves. Currents move beneath the surface. Storms can transform the ocean into mountains of moving water. And yet, the ship doesn't simply fight the ocean. Its hull is designed to work with it. A ship is not perfectly rigid in the way you might imagine. Its structure is engineered to withstand enormous forces while its hull moves through waves. It rises,
Falls, rolls, pitches, and continues forward. The ocean isn't simply something the ship travels across. The ship is constantly interacting with it. Think about how extraordinary this journey is. Humans first watched branches float. We tied logs together. We built rafts. We learned to sail. We built larger ships. We discovered steam power. We developed engines.
We learned about buoyancy, fluid dynamics, propulsion, stability, and materials. And eventually, we built floating cities of steel. But the basic principle never changed. And human imagination turned that knowledge into something enormous.
A giant ship may look like a victory over nature. Thousands of tons of steel crossing an ocean, carrying machines, food, fuel, and products between continents. But look closer. The ship isn't defeating the ocean. It's cooperating with it. Water pushes it upward. The propeller pushes water backward. The water pushes the ship forward. Waves move beneath it, and the hull responds. The ship moves because the ocean allows it to. From a fallen leaf, to a wooden raft, to the largest ships ever built, the story is the same. Humans didn't create the rules. We learned to work with them. Because engineering at its greatest isn't about conquering nature. It's about understanding nature well enough to move with it. Physics inside nature. PhyTure channel.